Hello dear students. In today's lecture we will discuss chi-square test. So let us start the chi-square test. These are the contents of chi-square test. First we will discuss the introduction. Then second is important terms. Third is application of the chi-square test. Fourth is calculation of chi-square test. Fifth is condition for the application of chi-square test, and the last one is example related to chi-square test. So this is the introductory part of the chi-square test. The chi-square test is an important test among the several tests of the significant developed by the statisticians. It is developed by the Carl Pearson in 1990. The chi-square test is a non-parametric test not used on any assumptions or distribution of any variables. This statistical test follows a specific distribution known as chi-square distribution. In general, the test we use to measure the difference between what is observed and what is expected according to an assumed hypothesis is called chi-square test. Second point is important terms. The first one is parametric test. The test in which the population's constant like mean, standard deviation, standard error, correlation coefficient, proportions, etc., and the data tends to follow one assumed or estimated distribution, established distribution such as normal distribution, binomial distribution, Poisson distribution, etc. So this belongs to the parametric test. Now the second is non-parametric test, the test in which no constant of population is used, the data do not follow any specific distribution, and no assumptions are made in this test. So this is non-parametric test. For example, to classify good, better, best, we just allocate arbitrary number or marks to each category. The third point is hypothesis. In the hypothesis, the statement of the population of parameter, definite statement about the population of parameters. The fourth is null hypothesis, a state that no association exists between the two across tabulated variables in the population, and therefore the variables are statistical independence. For example, if we want to compare two methods, method A and method B, and its superiority, and if the assumption is that both the methods are equally good, then this assumption is called the null hypothesis. The fifth is alternative hypothesis. Suppose that the two variables are related in the population. If we assume that the method A is superior than the method B, then the assumption is called alternative hypothesis. Now the sixth point is degree of freedom. It denotes the extent of independence, means freedom, enjoyed by a given set of observed frequencies. Suppose we are given a set of n observed frequency which are subjected to k independent constant, then degree of freedom equal to number of frequencies minus number of independent constant of them. In other words, degree of freedom equal to r minus 1 into c minus 1. What is r? R is the number of rows and c is number of columns. So this is the formula of degree of freedom. Now the next point is contingency table. When the table is prepared by enumeration of quality data by entering the actual frequencies, and if that the table represents occurrence of two sets of events, that table is called the contingency table. It is also called the association table. Now the next point is application of chi-square test. In chi-square test, generally we test three types of the application. The first one is test of independence of attributes. The second is goodness of fit of distribution, and the third is test of homogeneity. The first one, the test of independence of attributes. This test judging whether two attributes are independent or not. That means to explain whether or not two attributes are associated. For example, suppose we may be interested in knowing whether new medicine is effective in controlling corona fever or not. The test is useful. In this situation, we proceed with the null hypothesis that the two attributes are independent, which means that new medicine is not effective in controlling the corona fever. When null hypothesis is rejected, it can be concluded that there is significant association between the two attributes. Now the second test is test of goodness of fit of distribution. This test judging whether observed data fit or match with expected data. Again I repeat, the test of goodness of fit of distribution of chi-square test. This test judging whether observed data fit or match with expected data. The chi-square test formula of goodness of the fit is summation of O minus E whole square divided by E. What is O? O is the observed frequency and E is expected frequency. This is the condition. If the chi-square calculated, what we calculate from here, the chi-square calculated is greater than chi-square tabulated. We have already the tabulated form of chi-square in every textbook. With n-1 degree of freedom, then null hypothesis is rejected, otherwise accepted. If null hypothesis is accepted, then it can be concluded that the given distribution follows the theoretical distribution. So this is the condition of goodness of fit of distribution. Now the third test is test of homogeneity. In this test, we check whether two or more proportions are equal or not. This test can also used to test whether the occurrence of the event follows uniformity or not. For example, the admission of the patient in government hospital in all days of week is uniform or not, can be tested with the help of chi-square test. Same condition, chi-square calculated is greater than chi-square tabulated, then the null hypothesis is accepted and it can be concluded that there is a uniformity in the occurrence of the event. Now the fourth point is calculation of chi-square test. Here the chi-square equal to summation of O minus E of whole square divided by E. What is O? O is the observed frequency, E is the expected frequency, and if two distributions are exactly alike, then chi-square equal to 0. Now the fifth point is condition for the application of chi-square test. The following condition should be satisfied before chi-square test can be applied. The data must be in the form of frequency. The frequency data must have the precise numerical values and must be organized into the categories or group: observed, recorded, and used, collected one random basis. All the atoms of the sample must be independent. Total frequency should be very large. That means summation of f0 equal to n. N is the total frequency, always greater than 50. It is distribution free test. The test is non-parametric test. The test is used for testing the hypothesis, is not useful for the estimation. So these are the conditions for to calculate the chi-square test. Now let us take example related to chi-square test. For example, a die is thrown 132 times with following result. Number turned up 1 to 6 is like this. Frequency, their frequency is 16, 20, 25, 14, 29 and 28. Is the die unbiased? Solution. Let us the hypothesis that the die is unbiased. If that is so, the probability of obtaining any one of the 6 number is 1 by 6. So that there is expected frequency is 132 into 1 by 6. That means it becomes 22. Now, along with the expected frequency, and work out the chi-square as follows. First, turn up 1 to 6 already given, observed frequency already given. Now expected frequency, we have just calculated the object frequency, expected frequency. So this is the expected frequency. Now O minus E of all is O minus E, this one, O minus E of all square, OI minus EI of all square divided by EI. So this is the table. Therefore, chi squared equal to, formula of chi squared is summation of O minus E of all square divided by E, that is OI minus EI divided by EI, that is 9. On substituting the value of OI minus EI summation divided by EI, we will get 9. Hence the calculated value of chi squared is 9, and the degree of freedom is n minus 1. N is the total number, n minus 1, that is 5. The table of chi squared for the degree of freedom of 5% level of significance is 11.071. It is from the tabulated data from the chi-square table. Now comparing calculated and tabulated values of chi-square, we find that the calculated value is less than the table values, and as such could have due to the fluctuations of the sampling. The data rest supports the hypothesis, and it can be calculated that the die is unbiased. So this is the result of the example. Thank you.